In our full data set, we have two categorical variables, gender and hair color, and one continuous outcome variable of age. So let's combine the two concepts that we've already looked at and compare multiple means. Just as before, when we were using multiple categorical variables, each subgroup gets its own cell in a contingency table. But now, instead of looking at how many winners in each subgroup, we can ask a more detailed question about each group. What's their age? We have the age for each person, and we can calculate the age of all the people in each subgroup. So this would be all the females who have red hair, their average age. We can also look at the collapsed averages. So this is all of the dark-haired winners regardless of gender. And here we can look at all of the average of all of the females regardless of hair color. We calculated this using the conditional averaging function average if. This is very similar to count ifs, so understanding what the ranges are, what the criteria are, is very similar. Again, I have a choice in how I want to display the data. What makes it easy for the reader to see? What addresses the questions I want to answer? I could plot gender as the variable on the x-axis and then have each of my hair colors be a different bar within the legend. And I get to use my hair color palette again if I do that. This allows me to compare within males. The light-haired winners are slightly older than the dark-haired winners, and the same for females. I can also switch what's on the x-axis and what's in the legend, and this allows me to look at, of all the light-haired winners, males win at an older age than females, and in dark-haired winners, males win at an older age than females. Either of those would be valid and useful for the reader. Another option would be to use a contingency table. I think I'll include that so that the reader can see all of the subgroup averages as well as the collapsed group averages all in one place. I'll need to format that first. Remember, this title is italicized, and I want to put a line underneath that. I also want to put a line underneath the labels that go across the top here. Let's also make this column a little bit bigger so that I can see the word average, and the same over here. I also want to distinguish that this is an average row instead of another level of that variable, so I'm just going to pull it down a little bit. I also want to make a line across the bottom of that table. So that looks good. I think I am going to continue using my hair color scheme. So let's put both of these into our write-up. Use this as a picture. A little bit smaller. I can grab my table. Here, the default is to paste it as a table, so I would just leave it that way, and it maintains all of the formatting that I did in Excel. As before, I can see that males are winning at a higher age than females are. There also appears to be a main effect of color on average age of award. Overall, light-haired winners are older than dark-haired winners. What about a relationship between the two variables? This pattern, light-haired being older than dark-haired, is present in both genders. Dark-haired actors win about 7 years younger than their light-haired colleagues. Similarly, dark-haired actresses win about 8 years younger than light-haired actresses. We can't compare the average ages of redheaded winners because there aren't any male redheaded winners. But in terms of the light-dark relationship between the two genders, it appears to be an additive effect. So let's write a few sentences about that. Let's tell our reader where to look. See figure 3. This would be table 1. This is our first table that we have. I also can include the specifics about how hair color affects the age. Again, saying light-haired winners are older than dark-haired winners and reporting those averages. As we said, this pattern is present in both genders. We want to point that out to the reader, then describe what it is. The dark-haired actors win younger than light-haired. Dark-haired actresses win younger than light-haired actresses. We can also throw in a comment about why we're not talking about the red-headed actors and actresses. Red-headed winners, all of whom are female, win at an average age of, 36.75. I think this answers most of our questions about the relationship between hair color and gender and hair color and age. But we do have one more question to explore within the data. Ignoring this variable of hair color, we now want to know whether the relationship between gender and age has changed over time. Time could be continuous or it could be categorical. We have the dates of all of the awards. But in this case, we're going to treat time as a categorical variable of decade. But we're going to treat it as an ordinal variable. Ordinal means that it has order. This is our first introduction into using a line graph. We can use this because this is displaying how data is changing over time, or how it changes in order. So across the x-axis, I've included each decade, and then we will report the average age for females in that decade and the average age for males in that decade. So how can we interpret this graph? It's a lot different than most of the other graphs that we've seen so far. But this visualization does confirm what we've seen in many of our other graphs. The average age for actors is higher than the average age for females. We can see that this line is higher than this one, and it stays higher throughout the entire course of the data. We also see that there appears to be a main effect of decade, and what that means is the average age of both genders is increasing as time goes on. We can see that in the graph, but we can also look here. The average age in the 30s was 38. The average age in the 2010s was 45. So that's an increase over time. We also see that most major increases and decreases in average age happen at the same time for both genders. This is best illustrated where there's a dramatic dip around the turn of the century, followed by an immediate increase. And we see that in both of the genders. However, we can see that the gap between men and women is not the same over time. Early on, men were much older than females. In the 30s and 40s, there's a 10-year difference here. However, in the last 2 decades, the gap has been less than 10 years. And in the 90s, there's only a 2-year difference between the two average ages. We don't have any inferential statistics to look at something over time, so we can only make observations. So let's put this in a write-up now. I think I want to put this up where we were talking about age before. I know it's going out of order, but I think that it will help with the flow of the story. Paste it as a picture. Make it a little smaller. Now let's write some sentences about it. As we said, there appears to be a main effect of decade, with the average age of both genders increasing as time goes on. One thing to notice, it's not increasing at every single decade. So maybe I want to throw in the term generally here. Generally increasing. The overall trend is that it has increased, but that may not be the case at every single point. We can also point out that these lines aren't exactly parallel with one another. We can see that the change in age is not the same for men and women. We're always asking, is the pattern that we see in general also the same for our different levels of another variable? In this case, it's not. We pointed out that this gap is not the same as this gap, and that must mean that they are not increasing in the exact same way. Early on, we said there's a 10-year difference here. In the last decade, this is only a 4-year difference. Here would be a good place to include some specifics. I want to talk about what those differences are. So let's go back to the data and look. We can see the change from the 30s to the last decade goes from 32 to 43 for women, only goes up 4 years on average for men. So I can say the average age of female winners increased from 32.4 to 42.27, while the average age for men only increased from 43.42 to 47. I can also include a few sentences about the shape. And let's put this up here when we were talking about how much it's increasing. Most major increases and decreases in average age happen at the same time in both genders. This is what we were talking about before, where we see this dip. We just want to draw their attention to that. So now let's try to organize this a little bit better. One thing to note is that our reader should never encounter a graph that they're not ready for. Our text should always be above our graphs. So since we're talking about average age in both of these, let's put both of these paragraphs up here. This is our first one, so we're going to call it figure 1. Let's see, where can we put this one? It's nicely over there. Make these the same size. Call this one figure 2. Let's make sure that those are referenced. Where's the first time that I talk about this graph? There appears to be a difference in the genders. Let's put this here. See figure 1. When do I first talk about this graph? There's a main effective decade, average both generally increasing as time goes on. Tell the reader, now you can start looking at figure 2. So let's do the same here where we put the text above the graph. Call this one figure 3. Let's make sure that this is referenced in the text. Figure 3. Here we can have them look at either figure 4 or table 1. Let's go through and see if there are any places that we should add some more detail. In here, I'm talking about the proportion of light-haired winners being similar for men and women, but I haven't included those proportions. So let's add that. Similar for men and women. Low is 29.55% for men and 38.64% proportion of dark-haired men, specifics, 70.45, is much larger than the proportion of dark-haired women. So let's include that. 43.18%. I don't want my reader to get too confused by looking at all of these at once, so I'm going to put this one here. They know to look there. Figure up. Let's put this text up at the top as well. Let's put these below. All right, that's a lot of information for a single write-up. We've looked at a lot of different ways of analyzing this data.